We're working on section 4.3 now, which is going to be logarithms. In this section, first of all, we need to talk about what a logarithm is. So if we have y equals log base a of x, we write this out as y is the power, a is raised to get x. So when we have things like log base 2 of 8, we want to know what that equals. Log base 2 of 8, this is the power the base is raised to get x. So we say 2, what power do I have to raise 2 to get 8? So 2 to what power equals 8? So this right here, log base 2 of 8, this is the power I raise the base to get the thing in parentheses. So 2 cubed is 8, so log base 2 of 8 is equal to 3. So we're going to go through and do a bunch of these, just kind of practice ones real quick and look at a couple cases. The second thing we're going to do is convert between logarithm and exponential form. And then we need to look at the inverse properties of logarithms and exponentials. Then we'll finish out condensing and expanding logarithms. So for these next group of these, let's look at log base 3 of 27, log base 4 of 16, log base 2 of square root of 2. Oops. Hang on. So log base 2 of square root of 2, and log base 5 of 1/5. And let's say log base 2 of 1/4. So for this, I want to think 3 to what power makes 27. So 3 to what power is 27? So the base is 3, so it's 3 raised to what power makes the 1 in parentheses. Since 3 cubes 27, log base 3 of 27 is 3. So for this one, log base 4 of 16. 4 to what power makes a 16? 4 squared is 16, so that one's 2. For this one, we got log base 2, so 2 to what power is the same thing as square root of 2. If you guys remember, half power is the same thing as square root, so 2 to the half power is the same as square root of 2. Here we get 5 to what power is 1 over 5. That will be a negative 1, because 5 to the negative first power will be a 1 over 5 to the positive first power down below. And for this one, 2 to what power is 1 over 4? Well, since this 4 down here is 2 squared, 2 to the negative 2 power will be a 1 over 4. Because 2 to the negative 2 power will be 1 over 2 to the positive 2 power. So as far as just evaluating basic logarithms, that's a method of doing it. We just go through and think, what power do I raise the little subscript to get the thing in the parentheses, and that'll do it. So next we have going between exponential and logarithmic form. So if we have an equation a to the y equals x, this is the exponential form. That is equivalent to y equals log base a of x, and this would be the logarithmic form. So basically what we're going to do is we're going to have some problems where we have to identify who's acting as a, who's acting as y, who's acting as x, and then convert it over to logarithmic form. Or you guys will be given logarithmic form and figure out who's y, who's a, who's x, and convert it back over to exponential form. So we're going to look at, say we have x equals log base 2 of 1/4, and we want to convert this. This is a logarithmic function, and we want to convert this to exponential. So we need to identify who's acting as what over here. So the x is acting as the y in this equation. The little subscript 2, that subscript 2 is acting as the a. And then the thing in parentheses, the 1/4, is acting as the x. So if we want to convert this to exponential form, we get a to the y. A is actually 2. Y is actually x. So 2 to the x equals x, and x is acting as 1/4. So we converted the original logarithmic equation over to exponential. Let's say that we had a to the k plus t equals m. So this is an exponential form. And let's say they want us to convert to logarithmic form. So a, lowercase a, capital A is acting as lowercase a. Y is the power, so k plus t is acting as y. And x is the stuff by itself on the other side of the equal, so the m is acting as x. So I identified who's a, y, and x, and now I need to write them over here in the logarithmic form. The logarithmic form is y equals, so y is actually k plus t in our equation, equals log base a is capital A of x. X is acting as m. So for these, we'll do one more, but the idea is you just kind of look at which side are you starting from, use that side to identify who's acting as a, x, and y in that side, and then convert it to the other side and just write in for them. So let's say we had one that is log base b of r equals k. So this is a logarithmic one. We want to convert to exponential form. And let's say we had s to the x plus 2 equals n. So this one is going to be an exponential form, and we want to convert to logarithmic form. So over here, let's start on this one, convert to exponential form. B is acting as the lowercase a. X is the stuff in parentheses, so B is acting as the a. R is the stuff in parentheses, that's x. And this piece over here by itself is the y value. So we get a, which is actually the b, to the y power, which is actually to the k power, equals x, which is the r. And then on this side, we have a to the y equals x. So a is acting as the s, y is an x plus 2, and then x is the n. So when we convert that over to logarithmic form, it's y equals log base a of x. So y, which is x plus 2, equals log base a is s of x, which x is really n. So that's how these types work. You just use that equation that we have right up here. You identify a, y, and x, and then you just convert it over and plug in a, y, and x. Or if you're going the other way, identify a, y, and x on this side and plug in for a, y, and x on the other side. So if you have that formula that we had up there, let's put it up there one more time. This formula, just write this down. That does the go between exponential and logarithmic pretty easily. Okay, so the next bit they're going to have us do is work through solving for x in a couple cases. So we want to solve for x. So first one, we got x equals log base 2 of 1/4. Second one, we have log base x of 1 over 36 equals 2. And the final one out here, we got log base 3 of x equals 2, let's say. Okay, for the first one, we're going to convert it over to exponential form. A is this low power here, so we get 2 to the y, which is x, equals 1/4. So this is a, this is x, this is y. So I get a to the y, 2 to the y is x, 2 to the x equals 1/4. And then I need to solve this for x. So to solve it for x, I can rewrite 4 in terms of 2. So I get 2 to the x equals, 4 is 2 squared, but we have the fraction 1/4. So this would be 2 to the negative 2. 2 to the negative 2 is a fourth. So we can get this down to x equals negative 2 using the thing we did from last section. Same base, 2 to a power equals 2 to a different power. So the 2's drop and you get power equals power. On this one, let's use the same idea. A is the x, parentheses stuff, or sorry, A is x is the parentheses stuff, and y is 2. So this converts over to a to the y, which is x to the 2, because x is acting as a, and y is acting as 2. That equals x, which is 1/36. So to get rid of the square, I take plus minus square root of 1/36. And then logarithms can only have positive bases. So since x is going to be the base of this logarithm, I have to get rid of the negative. You can only have a positive base of a logarithm. So we're going to take the square root of the top of the fraction and the bottom. Square root of 1 is 1. Square root of 36 is 6. So we get down to x equals 1/6. Out here, a is 3, x is x, and y is 2. So I get 3 to the second power equals x. It's a, which is 3, to the y, which is 2, equals x. 3 squared is 9, so 9 is x. That one's not too much to do there. So on these solve for x types, you're still really using that equation from the last group of problems. You identify who's acting as a, x, and y, convert them to exponential form, and they should not be too bad to solve. Next idea is we want to go through and note that exponential and logarithms, as long as the bases are the same, are each other's inverse. So if f of x equals a to the x, then f inverse of x is log base a of x. So if you have an exponential of a base and a logarithm of the same base, they are each other's inverses. Again, the base, those a values have to be positive and they can't be 1. So if we remember from section 4.1, if you have two different functions and you know they're each other's inverse, then the composition of the two functions with each other becomes x. So we have f composed of f inverse of x is x, and we have f inverse composed of f of x equals x. So I've told you guys that as long as the bases match, these are each other's inverses. This generates two equations. This one here becomes a to the log base a of x is x, and this other one becomes log base a of a to the x equals x. So if you have an exponential of base a and you apply it to a logarithm of base a, the exponential and the logarithm sort of undo each other and the x is returned. And if you have it flipped around where you have a logarithm applied to an exponential and the bases match, the logarithm will undo the exponential of the same base and you get x returned. So we're going to use these two ideas, sort of these two equations here. We're going to use these to do the next group of problems. And they're pretty straightforward. It's not too bad. Okay, for this next group, suppose we have log base 4 of 4 to the 7th power, and we want to solve that. And suppose we have 7 to the log base 7 of 3. You guys will see some homework questions like this. Well, the logarithm base 4 is going to undo the exponential part of the base 4, and the 7 will be returned for the top case. For this bottom, since you have an exponential base 7 and the logarithm base 7 match, so this top one we kind of use this equation over here, the right-hand equation. This bottom one we're going to use the left-hand equation. The 7 is base A, log base 7 is the same base, so the exponential and the logarithm sort of undo each other, and you'll get the 3 returned. So at this point, we got 2 more of these we're going to look at. Then we're going to do something that's called expand and condense logarithms. So these are kind of the last 2 before we get to the final topic in the section. So they want us to solve log base 5 of x equals 2 and log base 8 of x equals 4/3. So when we go about solving these, again, we can use our a to the y equals x formula. The base is acting as a, x is acting as itself, and y is the part out here to the right of the equals. So we get a to the y equals x, and this is 25 equals x. So not too bad. Here a is 8, x is x, and y is the part by itself. We get a to the y equals x. This is the cube root of 8 to the 4th power. When you guys have a fractional power, the 3 tells you guys the root, and so the 3, the lowercase, tells you guys the root, and the 4 tells you guys the power. So cube root of 8 is 2. So 2 to the 4th power is x. 2 to the 4th is 16, so 16 is x in this case. So again, we kind of went back to the a to the y equals x equation, and that did everything we needed. The final part in this section is going to be called properties of logarithms. So this is properties of logarithms. So there's kind of 3 properties. If we have log base a of x times y, that's log base a of x plus log base a of y. If we have log base a of x over y, that's log base a of x. And the part that came from the bottom, the y, that's in the denominator, that one gets the negative. So log base a of y. So you can tell when you guys put these back in fractions, how you tell who's supposed to be in the top and who's supposed to be in the bottom is stuff with the negative sign goes downstairs. Stuff without the negative stays up top. Suppose we had log base a of x to the r power. The r is able to push out front of the logarithm, and you guys get r times log base a of x is the equivalent form. So these are our 3 properties of logarithms, and we're going to use them to do what's called expand and condense. When you expand, you go from the compact left-hand side and you convert them over to the expanded form right-hand side. When you guys condense the logarithms, you're given stuff in this expanded right-hand side, and you're going to push it back together into a more compact side on the left. So we'll do 2 or 3 examples, and that'll wrap the section up. So suppose we want to expand log base a of ab squared over square root of k. So for this, before we start trying to split up powers or stuff, this is split into a top and a bottom by the division sign. So I need to split the division up first. So I'll get log base a of the top, which is ab squared, minus log base a of the bottom. The bottom is square root of k, so that is going to be square root of k. Next, this multiplication here needs to split up. So I'm going to use the first property of logarithms. So I'll split the multiplication up as an addition. And I'm going to flip square root of k to k to the 1/2 power. So you guys can see we started with this compact form when we split up the division as a subtraction and we split up the top part as an addition. The last thing is to push the powers out front. And we'll get log base a of a plus 2 log base a of b minus log base, 1/2. 1/2 gets pushed out front, minus 1/2 log base a of k. And this is our fully expanded form. So we're using the properties of logarithms we had here. We're using them from starting from the left-hand side and pushing over to the right-hand side. So we're going to do another expand, and then we'll do a condense. And the condense is kind of starting from this form and just doing the reverse till you get to the compact form. So it's just kind of the reverse of what we're doing here. So this other one we want to expand log base 4 of b divided by t squared times r. So just like in the previous one, when we get started, we need to split the division up first. So we'll get log base 4 of the top minus log base 4 of the bottom stuff, t squared times r. Now we need to be a little careful here. We're going to split up the multiplication next. So this is going to be log base 4 of b minus, and I need to use parentheses when you split up the into a multiplication on a term with a negative. The negative is supposed to apply to the whole term, so the negative will apply to everything that the term breaks into. So when you split this up with the addition, you need to make sure that this negative applies to the whole term still. This is where people on tests and stuff, this is where they usually make the mistake, is they split it up as a positive, but they forget that the negative has to apply to both the terms. So the negative distributes, and I'm going to push this second power out front as well in this next step. So we got the negative, the 2 that was in the powers pushed out front of this term now. And then the negative distributes to the other term. And a way you can check is stuff that was originally in the top should end up positive. Terms that came from the bottom, the t and the r, those terms should have negatives attached to them. And that's kind of a way you can check and make sure you haven't dropped a negative sign over the course of it. Okay, and let's look at one condensed. That'll be kind of doing the reverse, where we start from an expanded form and we want to push stuff back together. So we're going to condense log base a of m plus 3 log base a of n minus log base a of t. So I'm going to pull the power 3 back inside first. So I have log base a of m plus log base a of n cubed minus log base a of t. Next, I'm going to rewrite the plus as a multiplication. So this will be log base a of m times n cubed minus log base a of t. And finally, the minus needs to go back as a division. So this is log base a of the top stuff, mn cubed. And the one with the minus becomes the denominator, all that over t. And this is condensed. Oh, I should say sometimes condensed, sometimes they say this as write as a single log. So instead of saying condense the equation, sometimes they'll say write the equation as a single log. And I should say also with expanding the equation, sometimes they write this as write as a log with no logs of products, quotients, or powers. So that's kind of the long way of saying expand. Like we have a product, so we have a multiplication, we have a quotient because we have a division, and t has a power. So if they say write it as a logarithm with no logarithms of products, quotients, or powers, that's a long way of saying expand it. And if they tell you guys to write it as a single logarithm, that's the longer way of saying condense it. And that's basically going to do it for section 4.2. So we'll stop there. Or sorry, this was 4.3. So that'll do it for section 4.3. 4.4 is really quick. So we'll stop there.